Today we're looking at two topics. We're looking briefly at the quadratic formula. We're spending most of our time with completing the square, and we'll start off with the quadratic formula first. So here we'll put the formula, we'll do a couple of examples that you can see down there below that, and that'll be the completing the square details. And so when we have a quadratic, we mean it's an equation that has the leading term with a power of 2. All right. Maybe there's a middle term, maybe there's a constant term, maybe not. You might have all three of them, but no more than that. And that's our standard form, okay? So here's the formula. You may have seen this before. This is a way to solve for x, so that's why we say x equals. And so we have negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So the a, the b, and the c that you're seeing here are referring to the leading coefficient, the coefficient on the middle term, or the constant term. Now, before we jump into the examples, there's a couple of details I want to point out with regards to order of operations, right? So if you think of your order of operations, and you think of the please excuse my dear Aunt Sally, P usually stands for parentheses. It's more than that, it's grouping symbols. It's all the grouping symbols is that very first step. And the division bar is a grouping symbol. So what that means is you're going to be simplifying everything on the top before you even think about the dividing, right? Because parentheses comes first, meaning you're doing the operations inside the parentheses. And the radical is also a grouping symbol. So you have a nested set of parentheses here. So we would do this section first, and then if it is a like term, then we'll combine it with the first term. Last, we divide away. Okay, so here we go. I want to make sure that all of my terms are on the same side. So I'm going to shuffle the terms to the right-hand side so I can keep my x squared positive. So x squared minus 3x minus 4 is what we have here. So my value of a is the 1, my value of b is the negative 3, and my value of c is the negative 4. Setting this up, when you see the negative b in the formula, we mean the opposite of b. So the opposite of negative 3. So this is what it looks like, and the opposite of negative 3 will turn into a positive. So we'll take care of that on the next step. Here's the square root of b, again, negative 3 squared. So wrap that in the parentheses because we have to square the negative as well. And then minus 4 times the value of a, which is 1, times the value of c, which is negative 4. All of that is divided by 2 times the value of a, which is 1. So again, remember that the idea is that we want to do all of the simplification on the top before we divide by 2. We'll clean up these negative signs in front, and then we'll spend a lot of our time here under the grouping symbol of the radical. So we have a positive 3 in front, plus or minus the square root of. Remember, when you square a negative, you always get a positive result because that's a negative 3 times a negative 3. That's why it's a positive 9. You multiply from left to right. So a negative 4 times 1, take that result, times negative 4. You get a positive 16. So the radical still exists, which means we still have these grouping symbols here, and so we're still working on the inside. 3 plus or minus root 25 is their like terms, and that's a perfect square, so we could still take a look at this step. So now the radical does not exist anymore, and now we're focusing on the outermost set of parentheses. That division bar is still there, so we're talking about this. We do want to combine like terms. So there's two possibilities. Either x is 3 plus 5 divided by 2, or it's 3 minus 5 divided by 2, right? So the idea is we have these parentheses here, so we need to combine like terms. So that'll give us 8 over 2, which simplifies to 4. Here we have a negative 2 over 2, so that simplifies to a negative 1. So those are the two answers. Now, we could have gotten those answers also by factoring, and this factors very simply. So each of the methods that we have for solving for x, whether it's factoring or quadratic formula, they all have pros and cons. There are certain instances where they are ideally suited. This one would have been better to solve by factoring, but we used a simple problem to illustrate the order of operations with our quadratic formula. Here's one that cannot be factored. Again, let's bring all of the terms to the same side. So we have x squared minus root 3x minus 5 equals 0. It might look really strange to have a coefficient with a precise value like this, the radical 3, but it'll work out okay. You'll see here in just a moment. So let's set this up. X equals negative b, so the opposite of negative root 3, plus or minus the square root of, Here's the value of b, wrap it in parentheses, so negative root 3 is being squared, minus 4 times the value of a, which is 1, times the value of c, which is negative 5, all divided by 2 times 1. So here we have the opposite of negative root 3, so that gives us positive root 3, plus or minus the square root of. Here you have the square and the square root, right? So you can think of that as if they're canceling out, but you really are multiplying this against itself. So it's a negative root 3 times a negative root 3. That's why you end up with a positive 3. Here, negative 4 times negative 5 is positive 20. Combine like terms underneath that radical, so that turns into a radical 23. Now again, the order of operations would say that you have to do the operation inside the grouping symbol. We have this grouping symbol here at the top. However, these are not like terms. The radicals are different. So you can't actually make them combine. So that's your final answer right there. And we can't simplify it any farther. So that's topic number 1. Let's take a look at completing the square. There's some very specific steps you have to go through, and they're detailed here. And I'll refer to the steps when we jump into the problem itself. But before we do that, there's a little bit of a mini skill that we need for some of these problems. And this is going to show up right here on step number 3 when we have to take half of b. b is that coefficient on the middle term. What happens if you have to take half of something? Well, that's the same thing as dividing by 2. So let me do a little brief introduction here with a simple value, and then we'll do what's printed on the page here. So let's imagine I have a value of b that is 4. If I have to take half of it, well, then that means you'll take the value b and you'll divide it by 2. So that simplifies really easily, no problem there. But what if your value of b is a fraction, right? We want to take the value of b, we'll plug it in right here, and then we have to divide it by 2. How do you do that? So that would look like 5 halves divided by 2, right? How do you simplify that? So think of this divided by 2 as 2 over 1. So you have a fraction on the top and a fraction on the bottom. Recall that when you divide with fractions, it's the same thing as multiplying by the reciprocal. Right, so the first fraction stays the same, 5 halves. You turn the division into multiplication and flip the fraction. So 2 over 1 becomes 1 over 2. Now when you're multiplying, you multiply straight across. So 5 times 1 and 2 times 2. That'll show up a little later on. I just wanted to address that first. So when we go through these steps, we're going to first of all make sure our leading coefficient is 1. If it isn't, then we have to divide every term by that leading coefficient. Then we're going to move the constant term to the other side. And then we'll do that half of b and we'll square it and we'll add that number to both sides. So let's see that work out here. So when I'm looking at this first example, you can see that 2 terms on the left-hand side, and while that's okay, I actually want to start kind of from square 1, if you will. So you're going to see me shuffle things back and forth, it looks like. But let me just get this into our standard form. So let me just format that as x squared plus 20x plus 19 equals 0. Most of the problems will start off this way where all 3 terms are on the same side. So let me just kind of take that first. So step number 1, make your leading coefficient 1. Well, you can see it already is, so we're fine. If that was something else like a 2 or a 3, we would have to divide everything by that value. All right, step number 2, move your constant term to the other side. Okay, well, as you can see, we're kind of shuffling it right back over again. So x squared plus 20x, leave some space, equal sign, minus 19, right? So when you move it over, you're subtracting 19 from both sides, and that's what we have. So that's what this is saying right here. So your left side should be in the form of 2 terms, your x squared term and your term of x. That's the left-hand side because the constant term has been moved over. So step number 3, now we want to take the value of b, take half of it, and then square it. That's what this box is for. It's our thinking space. That's what it's illustrating. Take the value of b, divide it by 2, take that result, and square it. So you can see our value of b is 20. So we want 20 divided by 2, take that result, and square it. So 20 over 2 is 10. We have to square that, and we get 100. That's the magic number, we have to add 100 to both sides. Again, we're adding the same value to both sides to keep the equation balanced. Now, the reason why this number is so special is because then we have a trinomial on the left-hand side, which can be factored, and it factors into two binomials. And the first is a perfect square, and the last is also perfect square. So factors of 100 will be 10 and 10. And if you were to FOIL this out, your outside terms is 10x, your inside terms is 10x, so 10x plus 10x is 20x. That's the middle term that you see right there. What you'll see is that this pattern is always going to give you two binomials that are exactly the same. So we're going to reformat this as a base of x plus 10 to the power of 2, because we have two copies that are being multiplied together. Here we'll combine like terms on the right-hand side, so negative 19 plus 100 gives me 81. So what we've done is we've taken the existing form, our standard form, and we've changed the format. It's still a quadratic because we still have a power of 2, but in this form it's now really easy to solve. We're almost there, 2 more steps and we're about done. So to get rid of the power of 2, let's take the square root of both sides. And when you do that, don't forget the plus or minus. On the left, the square and the square root cancel out, leaving you with the x plus 10. And on the right-hand side, you have plus or minus 9. So then we're going to move the constant term of 10 to the other side by subtracting it away. And this is how you isolate the variable. So again, we have two problems because of the plus or minus 9. You have a positive 9 where you're subtracting the 10. And then you have a negative 9 where you're subtracting the 10. So you end up with negative 1 and negative 19. All right, so those are the two results. So here our answers happen to be integers. We won't always have integers. We might have something else. That's what we'll see here in a moment. But that's our first example. So let's take a look at part B. You can see we have all the terms on the left-hand side, so it's that form we need, so we're good to go. Step number 1, make your leading coefficient 1. If it's not, divide every term by a. So you have to divide both the left and the right side by 4. Right? Do the same thing on both sides of the equation. So 4x squared divided by 4 is just 1x squared. Negative 20x divided by 4 is a negative 5x. And when you look at this, this might seem strange. 17 divided by 4, you might think it doesn't divide. Well, what you mean is it doesn't divide evenly, but you can still divide 17 by 4, and we just represent it as a fraction. There's 17 divided by 4, and it just sits in that fraction form. Of course, 0 divided by 4 is still 0, so nothing really happens. Step number 2, move the constant term to the other side. So you have x squared minus 5x equals, remember to change the sign when you move it to the other side. So now we have to figure out what special number we're going to add to both sides. So go to your thinking space, find the value of b. We don't want the original b. We are using the current b, which is the negative 5. So negative 5 divided by 2, and then we have to square the whole thing. Now, of course, negative 5 does not divide 2 evenly. Don't go to a decimal. You might think that's easier, but it's not. Just square the values. So the numerator squared is a positive 25, and the denominator squared is a positive 4. So that's what we're adding. We're adding 25/4 to both sides. So that might look scary with the fraction on the left-hand side, but it will factor using the same pattern we saw previously where the two binomials will be exactly the same. Here's how you factor a fraction. So again, we start off with x. Notice the middle term is negative, so we also need negatives here on our factors. Then we have to factor the fraction. That means we need fractions here, so there's my fraction bar. And now think about this. When we multiply these together, we should get the x squared in front, and we should get the 25/4 in the back. So what do I need to multiply to get a 25? Right? What numerator times what numerator gives me a 25? And again, they have to be exactly the same. What denominator times what denominator gives me a denominator of 4? So that's 2. So we have 5/2 as the fraction in our factored form. And again, reset that as a binomial squared. So there's my x minus 5/2 to the power of 2. On the right-hand side, we already have these fractions with a common denominator of 4, so we're ready to combine them. So negative 17 fourths plus 25 fourths adds up to a positive 8 fourths, which of course happens to simplify to 2. So now we're just a couple steps away from solving. We're going to extract the roots. So here's the power of 2, so take the square root of both sides. Don't forget your plus or minus. So x minus 5 halves is on the left. On the right-hand side, you just have plus or minus root 2 because that does not factor or simplify in any way. So now add 5 halves to both sides. So x equals 5 halves plus or minus root 2. And we'll just leave it this way. I know you could create a common denominator and combine those over a common denominator of 2, but we'll just leave it that way for our purposes, and that will be just fine. Now what we're going to do is do one more example on the inside of the page. We'll look at one of the homework problems and do that as an additional example because we want to come back and look at this skill here. We started off with this skill where you have a fraction divided by 2, and we haven't actually seen that show up in either of these examples. So we're going to go and take a look at one of our hardest problems on the homework set and use that as an additional example, and we'll talk about this as well. So if you'll go to the very back page, number 16 is what we'll use as our additional example. The reason why this one is very challenging is because all of the work with fractions. There's a lot of steps here, but you'll see that many times the issue is, can we deal with fractions? So things like adding fractions, multiplying fractions, squaring fractions. And that's kind of the emphasis on this problem here. So let's get started. All of the terms are on the same side, so we're ready for the very first step. Your leading coefficient must be 1. If it's not, divide everything by that. So here's 9, okay? So 9m squared divided by 9 is just 1m squared. Negative 20m divided by 9 is just negative 20 divided by 9. So obviously that does not reduce. Here you have negative 21 divided by 9. Now that one does reduce, but we don't really have to. It'll work out okay if we leave it this way. So I'm just going to leave it there. 0 on the right-hand side. Next, move the constant term to the right. So we're adding 21/9 to both sides. And now we come to the critical step. We have to figure out what number to add to both sides. And I'm going to need a bit of thinking space, so I'm going to use this space over here on the left. We're trying to figure out this. We want to find the value of b, divide it by 2, and then we want to square the whole thing. That's what we have to add in. But my value of b is a fraction. So when I plug it in, it looks like negative 20 over 9 divided by 2. That's what we have to simplify, and then we have to square the whole thing. So let's focus on the inside. I want to take that divided by 2 and treat it as a fraction like 2 over 1. Then we'll change the division into multiplying by the reciprocal. So to reformat this, it looks like, here's your first fraction of negative 20 over 9. Change that division to multiplication. Flip the fraction upside down so it's 1/2. Again, all of that will be squared eventually, but on the inside, you can see that we have negative 20 over 18, and we'll be squaring that. Now, if we try to square that right now, we're going to get really big numbers, right? So I'm thinking I don't want to have such big numbers. I know we didn't reduce this fraction here. We could have. That would be fine, but it'll work out just fine for us in this case. But this one, yeah, that's just a little too big. So let's reduce the fraction first. So I'm going to reduce that to negative 10 over 9, and then I'll square that. So that'll be a positive 100 over 81. Okay, so let's work with this. I'm adding 100 over 81 to both sides. So that was my thinking space just to figure out how to take the value of b, cut it in half, and then square the result, and that's the result right there. So the left-hand side is now a trinomial that can be factored. So again, you should have identical binomials, starting off with m. The middle term is negative, so we need a negative sign here as well. The constant term is a fraction, so I need a fraction here. And now we think, what numerator times what numerator gives me the 100? So 10 times 10. What denominator times what denominator gives me the 81? 9 and 9. So those are identical, so you can see we will rewrite that as m minus 10 ninths quantity squared. So we have a little bit of work here on the right-hand side because I want to add fractions, but they don't have a common denominator. We have to create a common denominator. We'll use that 81 because we can take the first fraction and multiply it by 9 over 9 to create that common denominator of 81. So what we have here is we have 189 over 81 plus 100 over 81. That means we can combine those numerators over the common denominator of 81. So that'll give us 289 over 81. Now we can extract the roots, meaning we'll take the square root of both sides. Don't forget your plus or minus. M minus 10 over 9 on the left. It just so happens this is a perfect square. We got fortunate here, so that's going to be a plus or minus 17 over 9. Next, we'll add the 10 ninths to both sides. So we've isolated the variable, so we have a positive 10 ninths, and then we have a plus or minus the 17 ninths. So again, there's two problems here because either we have 10 plus the 17 over the common denominator of 9, or we have 10 minus the 17 over the common denominator of 9. So we end up with a result of 3 or negative 7 ninths. All right, so that one doesn't simplify any further, so there's the final two answers.